So 10.1, we are working with adding and subtracting polynomials together. Now, before we do the actual process of adding them together, I do want to go through a couple specifics and some terminology that's showing up here and is crucial to this material as well. So we want to start off with our definition of what terms are. So terms are a couple different ways we can see them presented. It can be a number or a product of a number and one or more variables, and those variables can be raised to different powers. So as we're seeing here, the number 14 is a term, 8x is a term, m is a term, negative 2t to the second power, that entire thing is a term. We get some big grosser ones like this, negative 3x to the third, y to the sixth. This entire thing, entire combination of stuff multiplying together is considered to be a term. And we need this because we need to make sure we know what it means when we're adding, subtracting like terms and unlike terms. And that's a bit further down in our material. And then we get to our definition of what a polynomial is. And a polynomial can be simply a single term or the sum of terms in which all variables and have whole number exponents and things like that. So we generally can see this written out as just the number 4, just as 9x. And then we start to see the more classic and kind of standard issue polynomials we will be seeing throughout the class and moving ahead. So we have 2m minus 4. We have two terms that are adding or subtracting together. We have, for this example here, we have 6x squared plus x minus 2. We have three terms here. We have this x squared term, we have this x term, and then we have this minus 2 in here as well. And then our last one, we have four terms, a to the third minus 4a squared plus 2a plus 7. So when we're looking at any polynomial at all, they are separated by addition and subtraction signs. That's how we're going to tell if we have a polynomial or not, and or if terms are and aren't adding and subtracting together. Now, we have some classifications for polynomials, and I want to take a quick pause here with these because these are both really nice to know and at the same time kind of sort of not critical to this particular class and what we're going to be doing with them. So we have this overarching idea, an overarching term of a polynomial, and polynomials adding, subtracting together. Within this umbrella idea of polynomials, we have some specific classifications for them based on the number of terms that are adding or subtracting together. So we have monomials, and this is just a single term. So a good example of monomials here would be, I'll try and highlight these a little bit. I'll use green here. So monomials would be something like 4 or 9x. I just have a single term that's just sitting there. No addition, subtraction taking place. It's just 4. It's just 9x. It's just negative 2t to the second power. That's about all we have there. For binomials, we're going to get some colors crossing here a little bit. It's when we have two terms that are adding or subtracting together. So that would be something like 2x minus 4. It could also be along the lines of, I'm just making up an example here. It could be something like 3x squared plus 7y. Make this plus a little bit better. So something like this would also be considered a binomial. There are two things that are adding or subtracting together. And then our last one that we have that we care about is called a trinomial, and it's going to be where we have three things that are adding, subtracting together. So if we're highlighting this, the trinomial would be something like, there we go, this 6x squared plus x minus 2. I have 1, 2, 3 things that are adding or subtracting together. And it doesn't matter which things are adding, which things are subtracting, as long as there are 3 of them that are adding or subtracting together. And anything that has more than 3 terms adding or subtracting together, we are just going to refer to as a generality, it's a polynomial. Nothing special about its names that we're going to be using or seeing. So the three terms that we're going to see most commonly are monomial, binomial, and trinomial. Anything bigger than that, you can go look up on your own. I'm not going to require you to know those or be familiar with them. The names get ridiculous, but we don't need to worry about that. And all of these are under the umbrella term of all being considered polynomials. So a lot of terminology there, but just noting that we've got things with one term, two terms, three terms, and technically more than that. But they're all polynomials at the end of the day. So with that, we have this last part here that shows up when we're looking at the degree of a polynomial. This is not something that we're going to be seeing a lot of in the class and not something that I really test anyone on, but it is good to know because it shows up a couple times in the homework and a couple times with some other material and stuff that we'll see in textbooks. So if we are asked, what is the degree of a polynomial? Well, the degree is the same as the term with the largest combined degree, which is the exponents. So if I'm looking at, we'll look at the terms that we have up here. So I have 8x, I have m, I have negative 2t squared, and I have negative 3 x to the third y to the sixth. The degree of 14, it's the same as the term with the largest combined exponents. So how many exponents am I seeing in this? I'm not seeing any at all. So this 14 would have a degree of 0. The 8x that we see here, well, I'm not explicitly seeing any degree showing up, but there is an assumed invisible 1 that is hanging out right up here with this x. So this 8x is actually 8x to the first power. So this 8x would have a degree of 1. The m also has nothing explicitly written there, but because there is a variable, it is also assumed to have little invisible 1 as a degree hanging out right up there. So the degree of m would be 1. If I'm looking at negative 2t to the second power, what's the largest combined exponent that I'm seeing here? Well, I have t to the second power. So the degree of this term is going to be 2. Now, if I'm looking at this last one that I have here, well, I have x to the third, and I have y to the sixth power. So what would the degree of this entire term be? Well, I have a degree of 3, and I have a degree of 6. I'm combining the degrees together. So this thing would have a degree of 9. The 3 and the 6 are going to add together, and the combined exponents are going to give me a degree of 9. Now, this is not something, again, that we're going to see very common. I normally don't like to test on it because it's kind of petty when we go through it and as we see it show up. There are some other ways that we will see it show up with standard form, and that's mainly where we're going to be using and applying this. So moving down to our standard form, this is just how we are going to simply rewrite polynomials after we've simplified them. So we're going to go through adding and subtracting polynomials together here shortly. And after we have done all of that, after we have fully simplified everything, and when we see simplify, remember, we're thinking to PEMDAS with that. We want to make sure that we are writing our final answer in what's referred to as standard form. And we have some guidelines that we're going to be following to make this happen. Now, this isn't a do these in any order. This is the priority that we list these things in, and we absolutely must follow that for our final answers. So if I've added some things together, if I've subtracted some things together, okay, great, no problem there. After I've added and combined together everything I can, I now need to make sure that everything is written in the correct order or standard form. So our first requirement is that the first terms are listed in alphabetical order. And with this, I will just be looking at, does this term contain a variable? Yes or no. If it does contain a variable, we list them first and foremost by alphabetical order. So everything that comes first in the alphabet is going to get listed on the left. Everything that comes later in the alphabet gets listed further to the right. If we have an instance where we have multiple variables that have the exact same, or multiple terms that have the same variable, like multiple things with X or multiple things with A's in them, we then look to list those in descending powers of the entire term, meaning the degree of that polynomial. So we will look to see alphabetical order first, and then if I have any repeating variables, then I need to see, all right, what's the degree of those that have repeating variables? Biggest power first, and then I descend in powers as I go left to right. So let's go ahead and take a look at two examples that we have right here for listing these things out. So I'm looking at y to the third minus 7z to the fourth plus 2x. I can't combine anything else together. Everything's been fully combined at this point in time. I now need to rewrite this into standard form. So which term is going to be going first? And all we're going to be doing is listing that out in alphabetical order. So between y, z, and x, which one would come first? Well, it's going to be x. X comes first in the alphabet. So I would list this first as 2x. I would then look to see what would come next in the alphabet. Would that be y? This is a positive because there's no negative sign written here. So I'm going to have 2x plus y to the third power. And then this z would come last in alphabetical order. So I'm going to have everything that goes along with that minus 7z to the fourth, listed at the very end. So I have things listed in alphabetical order. That's my first priority and first rule with standard form, and I need to follow that at the beginning. I don't have any repeating variables showing up in here, so I don't need to worry about descending powers and how do I order multiple x's or y's or anything like that. And as we see here, that's the same as our final answer that's written out. Looking at our second example, now we're going to have some repeats of things showing up. I'm looking at this and I see that I have 10xy minus 5x to the third power plus y to the ninth power. So rewriting this thing in standard form, my first rule needs to be in alphabetical order. So I have x's and y's. This first term has x and y included in it, but because x comes before y, it is going to be listed before just the y to the ninth term. And now I have the issue of I have an x here and I have an x showing up here as well. Which term is going to have to go in front? Well, with that, I look to my second rule in standard form, descending powers of the entire term. So what is the degree of this entire term here? Well, as you remember, if I don't have a anything explicitly written in there, yeah, I'm going to have to look and write in some ones in there. So I have x to the first, y to the first power. What's the combined degree of this polynomial, or this term, I should say right here? The combined degree is going to be 2, because I have 1 plus 1. I'll make a little note of that here. This thing has, shorthanding it, oops, this has a degree of 2. So I'm looking at this thing with an x and a degree of 2. I'm looking at 5x to the third. That has an x, and this has a degree of 3. So it's got a higher power that's showing up here, which means that this term is going to need to be listed first. So I can write that down below. We got the little clicking thing off to the side. There we go. So we would have negative 5x to the third. We then have this plus 10x, y. And then the y to the ninth, that doesn't have any x's in it, so it's going to have to go at the very, very end. I'm going to be adding y to the ninth here. We can check our answer. Oh yeah, this was a typo on my end. Apologies, this should be moved around. There's always something that's a typo within these. Good thing we're finding it now. There we go. All right, that's the better one. Okay. So that's our main process that we're using for standard form of polynomials. Alphabetical order first, and then by descending powers if we have repeating uh, exponents or sorry, repeating variables showing up there. Okay. So standard form written in here, we're using this at the very end after we've done simplification with everything else. And then we have our introduction for terms and polynomials up here. So go ahead and move on to the main part of this, the real meat of this particular section. That's where we're going to actually be adding and subtracting polynomials together. I'm gonna try and position this here. Okay, perfect. So the main thing that we are going to be looking for when we are adding and subtracting polynomials together is this idea and this thing that we refer to as combining like terms. So if you are writing any notes down, which I'm hoping everyone is doing, or typing them off maybe on a screen separately to this, combining like terms is the main thing that we want with this. Combining like terms also only works when we are adding or subtracting polynomials together. Combining like terms does not apply when we multiply, divide, raise polynomials to powers, or anything like that. It is strictly for adding and subtracting polynomials together. So what do we refer to as combining like terms? What is the definition of like terms? Well, we have two criteria that show up with this for like terms. And if you are writing this down for yourself, which is fantastic, please, please, please highlight, star, circle, put brackets, whatever you need to around it. These are the two big requirements that we have for combining like terms now and forever moving forward, whether it be this math class, your next math class, calculus, multivariable differential equations, physics, all that good fun stuff. If we're using X, if we're using theta, the Greek alphabet, whatever it may be, this requirement holds true. So the requirement is this. For two things to be like terms, they need to fulfill both of these criteria. They need to have the exact same variables in them. So if one variable has X, or one term has X, the other term better also have X. If one term has AB in it, well, then the other term better also have AB in it. The second requirement is that all of the variables have the exact same exponents that are showing up within that. So going back to our example, for the quick made up one that I had, if both terms have x in them, awesome. But if one is x squared and the other is x to the third power, those exponents are different, and therefore I do not have like terms, so I cannot add or subtract things together. We're going to go through 4 examples of this, and I'll show you guys some other examples or places for other examples afterwards. But this is the very, very, very hyper strict set of rules that all like terms need to follow. If one of these rules is broken, then I cannot combine or add or subtract the terms together, and they must stay separated, meaning I can't do anything else with them. Now, it should be stated, if we do have like terms in here, we are only going to be adding or subtracting the coefficients together. And the coefficients are the bigger numbers that are sitting in front of those terms. So if we're taking a quick glance down at the examples, the coefficient for this term here would be 5. The coefficient here would be 4. The coefficient here would be 2. Coefficient here is 3, and so on. So it is only going to be the coefficients that will add or subtract together if I have like terms. And again, these are the two criteria that we absolutely must have met to be able to combine them together. Now, the big warning also, and again, similarly to these ones being rules that we want to have written down, big warning to everyone right here. When we are combining like terms, meaning adding or subtracting terms together, variables and their exponents absolutely never, ever change when we are combining like terms. It is only the coefficients that will change, either increase or decrease. So if you are writing things down, and I'll give a 30 seconds or so here before we dive into the examples for people to write things down with it. If you are writing notes down, please, please, please use red pen, use highlighter, use something to put some big circles around or red stars or warning labels, something like that to note this for yourself. This is something that a lot of people unfortunately do, and it goes and makes things way, way harder with these problems than they need to be. And we get wrong answers as a result of this. So when we combine like terms, it is only the coefficients that add together. The variables stay the same and the variable exponents stay the same. They never change. Okay. Okay. Now, the last couple parts that are worth noting with this, and we'll see this with the examples as well. Make sure that you are tracking any and all sign changes that take place from the distributive property correctly. Um, as we have seen, and you don't need to go down to the React and do the raise hand thing with this because, I'm pretty sure we're all in a similar boat with this. You could do it over on your end of the computer with this. Um, how many people have been hit by a negative sign and it's thrown things off? Yeah, I'm telling myself that everyone is raising their hand on their side of the screen. Um, that still ends up showing up here. It still ends up getting a lot of people with these types of problems in polynomials. So we will have the distributive properties showing up with these, and I do think it is worth taking an extra line or two to very carefully write these things out and show any and all sign changes that take place before you actually combine like terms. So our first example that we see here, I've got a minus sign showing up with the polynomial. Yeah, this minus sign is going to affect everything inside here. Looking at number 3, this negative is also going to affect everything inside here. We're going to go through these examples and show how we rewrite them and how we set these things up and solve them out and show our work accordingly. And then last but not least, once we have fully combined all like terms together, we then need to rewrite our final answer into standard form. We only rewrite into standard form at the very, 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 very end of the problem. We never do standard form early because we may end up needing to add or subtract some other things later on. And again, a thing we do at the very end of a problem. Okay. So I'm going to take a pause here for about a minute. If anyone has any questions, go ahead and give me the raised hand thing in the chat. I'm going to give you guys, again, about a minute or so if you still need to write down any of these notes. Take some time to do that. Now we're going to jump into examples 1, 2, 3, and 4. So going into example 1 that we have here, we are told to simplify this expression. Now I have a binomial subtracting with another binomial. Each have 2 terms, so bring a little bit of that terminology that we covered earlier on in the class back to terms here. So I have this minus sign here, and I have this first binomial minus the entire second binomial. Whenever we have a subtraction sign that's showing up or anything seen out front here, it can be useful to think of this as being a -1 that's sitting here. Now, this -1 does need to distribute through, and this will affect everything in this second set of parentheses because I effectively have -1 multiplying with everything here. With my first binomial, you could think of it as there being an invisible +1 sitting in front. But a +1 times anything isn't going to actually change any values. So this first binomial is going to come down exactly as it was with no changes. This negative, however, is going to distribute through and is going to start changing signs with what's inside here. So a -1 times 4y, that's going to change this to be a minus 4y. 4y went from positive to a negative. And then this -4, well, a negative times a negative is a positive, so I'm going to end up getting +4 written out here. Now that we have everything multiplied out, we have no more parentheses showing up, and we can start combining like terms together. Now, I want to be clear with this, with the 4 examples that we have. I'm going to try and show you guys some different ways you can do this. There are numerous ways that you can go through and combine like terms and put everything together and organize them for yourselves. I recommend doing something to help organize this, especially if this is something that we are struggling with a little bit on the homework, or as we're going through this stuff in a bit more detail. So I want to combine like terms. So where are my like terms? So I have something with a y in it, something without a variable, something with a y, and without a y as well. So what I can do is I can take a line if I want to, and I can start putting the like terms next to each other. So I'm just reordering these things, keeping the term and their corresponding signs together, noting that I had a positive 5y, I have -4y, and I'm just putting the y's next to one another right here. I'm putting the constants next to each other right over here. Some people also like to write these things with some underlines or circles or different colors. They'll say, here's my like terms, different color. Here's some other like terms. And now I have the like terms written next to each other, and it's easier to see what things will combine together. So I have 5y minus 4y. Remember, when I combine like terms, the variables and the variable exponents stay the same. It is only the coefficients that will add or subtract together. So the y stays the same. 5 minus 4, that's going to give me 1. Well, I could write this out as 1y if I wanted to. Now on the back end, I have 4 plus 4. That's going to give me 8. And then the last part that we will do, we don't normally see 1y listed for final answers. Be careful if you enter that into WAMAP. It might say, hey, your answer is not fully simplified. Make sure that you drop that 1 and just write it in as y here. Then the last thing we check, is this thing in standard form, meaning alphabetical order first for variables and things, and then by descending powers. Well, we always want to have constants, meaning terms that are just numbers, always at the very end. They're always on the furthest part to the right. I only have a y term showing up otherwise, so variables are in front, constants at the end. Perfect. This thing is written in standard form, and I am good to go, and that's going to be my final answer. For example 2, we've been given 2x minus 3y plus 1. And we are adding the polynomial. I need to move this over a bit. 7x plus y minus 5. Okay? So I have a trinomial plus another trinomial. I have 3 things that are adding or subtracting in this first polynomial, and I have 3 things that are adding or subtracting in this second polynomial. So that's where we get trinomial plus trinomial. Now, it doesn't matter if it's monomial, binomial, trinomial, adding or subtracting to one another. We're still going to combine like terms and use the distributive property as necessary. So looking at my first trinomial, I have a positive in front here, so that's not going to change anything. This whole trinomial is going to stay the exact same. I'm also adding this second one, and we could think of this again as having an invisible 1 in front. So none of the terms inside here are going to have any sign changes showing up with them. So I can just take a line below this to rewrite everything here outside of parentheses. And we prefer to do this rewrite before we do any kind of combining like terms, because parentheses can make things a bit weirder as we're doing that. Now I'm looking for any like terms that I could combine together. So I'm going to use a highlighter here just to show a different way that you could go about organizing these things. Do I have any like terms showing up? Well, I have two x terms showing up right here. So I'm going to go ahead and combine or just highlight those with yellow just to show, hey, these things are the same. I don't have any other x's, so that's the best I can do there. Do I have any other like terms? I'm noticing, yeah, I've got this y term and a y term here. So those are like terms. We're going to highlight those in green just to show them as being like terms here. Make sure if you are doing this, you are using the term and the sign in front of it for combining like terms. And then last but not least, I have coefficients, or not coefficients, constants, I should say. I'm adding 1 here, and then I'm subtracting 5 here. Now, you're welcome to use this bit of color coding with highlighters and things like that. You don't have to. Just want to show a different option that some people like to use. I'm now combining like terms. I have the 2x plus 7x. Only the coefficients, the big numbers in front, add together. The variables and the variable exponents stay the same. So this combines together to give me 9x. I have negative 3y plus y, just the coefficients add together. So I have negative 3 plus 1, effectively. So I'm going to have a negative 2, and then bring down the y, the variable and its exponent, exactly as it was. And then plus 1 minus 5. So 1 minus 5, that's going to give me minus 4. So I've combined everything together as best I possibly can. Then I always check for myself, is this thing in standard form, alphabetical order, and by descending powers? Yes, it is. Fantastic. So I do not need to do any extra work. I have my final answer right here. So again, I have two trinomials showing up here, 3 terms and 3 terms. In this case, they are now subtracting with one another. So whenever I see that subtraction sign, I'm going to have sign changes taking place. Again, it's your choice if you would like to do this. You can, it's loading here, you can put that invisible 1. Oops. It's got the loading bar going. Can't write anything in here while that's happening or change the colors. But if you would like to put an invisible 1 in front here, it's not explicitly written in the problem, but you are welcome to do so if that would be helpful. If you don't want to do that, that's perfectly fine as well. You don't have to. Just make sure that you are denoting somewhere in the problem that the negative sign does have to distribute through to everything inside of this second set of parentheses. So I'm going to see if I can, oh, there it's going now. I could write it out like this as well and show that this negative goes through. So my first polynomial is going to stay the same. It has a positive in front of it. Or it's put this way, there's no negative in front here, so there's no sign change that takes place. Negative distributes through. This 2x squared is going to become minus 2x squared. This negative or minus 8x, this changes. Becomes plus 8x. And the 4 that's positive becomes a minus 4 at the very end. So now that I have everything distributed through, all of the sign changes were done accurately, I'm hoping. Now we can go through and combine like terms. So we have 2 ways that were shown up here. We'll let you know now that on the homework or on the test, I do not care which of these organizational methods you would like to use, or if you'd like to come up with some other ones that are helpful to you as well, you're welcome to use those. Another one that I have seen people do, I'd be a little bit cautious with this one, but some people like to come off to the side and then write the like terms combining together off to the side. And what that would look like is something like this. Making a quick bullet point, noting that we have x squared minus 2x squared. My like terms here are adding together. This ends up becoming negative x squared. For my x's, I have minus 4x. I have positive 8x, and write that in. When I combine these together, only the coefficients. I'm going to get a positive 4x showing up there. And then I have a positive 7 minus 4. 7 minus 4, that's going to give me negative 3. So I combined my x squareds together, I combined my x's together, and I combined my constants together. And they're all simplified right over here. And now I need to just make sure that I but I write these things out in standard form. So standard form is alphabetical order by descending powers. I'm noticing that I have two terms with x in them, so these are going to go first. But which one is going to go in front of the other? Well, that's going to be the one that has the higher power, the higher exponent attached to it. So I'm going to have this negative x squared in front. And then I'm going to have the plus 4x. And then the constant terms are always going to go at the very, very end, furthest right. These. Again, just trying to provide or show you guys just another way that you could organize these things for yourself to combine like terms. What we did right over here. If you'd like to use this, you can. If you'd like to use one of these other methods, you can totally do that. Just do something that's going to help you tell, here's the like terms, here's the non-like terms, and which ones are combining together. Okay, we'll take a look at number 4 here. And we'll end the recording and then take any questions that you guys have over this material or other stuff that was covered in the past or the homework or anything like that. So our fourth example, this is where we've got a lot more things going on. We have 3x squared plus 1 minus 5x plus 9. Then we're adding negative x squared plus 3x. Okay, so now I have 3 things that are adding or subtracting together. From here, again, I want to make sure I get everything out of parentheses first, because parentheses are what makes this thing a bit more challenging. So what I want to do first, deal with any positives or negatives in front of these sets of parentheses, and then we can start actually combining like terms. So I have an invisible 1 in front of this first one. If you wanted to put that in there, you could. Again, you don't have to, and it will never be written that way, but you could if that would be helpful. So my first polynomial is going to be rewritten just as 3x plus 1. This negative is going to distribute through, which means that this 5x is going to become negative 5x. The plus 9 is going to become minus 9. And then for our last one, it's going to stay the exact same. That negative x squared is going to stay negative x squared. That 3x is going to stay as a positive 3x. And now from here, we can do and use any of the previous methods to organize and combine like terms how we would like. I'm going to go ahead and just do some underlining with this one. So I have 3x squared and I have negative x squared. Okay, so those things are going to combine together. I have a plus 1. And let's see, where else do I have? I've got a minus 9 here, so another constant. Okay, no other constants showing up. And then I have a minus 5x and a plus 3x. Okay, so those things can combine together. And then if you would like to skip the rewriting step, where we actually physically rewrite these things next to each other, you can do that. It's not required, but you do need to make sure that you are combining the coefficients correctly. So 3x squared minus x squared, that's going to give me 2x squared. I have a positive 1 minus 9. That's going to go ahead and give me a minus 8. And then I have negative 5x plus 3x. That's going to give me a negative 2x. I just combine these things together going left to right. So I've combined everything together that I can. I now need to make sure this thing is in standard form. So alphabetical order first, then by descending powers. So I see that I have the x squared in front, so my variable terms in front here. I need to always put constant terms at the very end. So we'll do that quick rewrite now. So 2x squared minus 2x minus 8. So I have my variable terms in front. Awesome. Are they by descending powers? Yeah, I've got x squared in front. I've got x to the first power written in after that. So this thing is written in standard form. And I am good to go from here. So last part I want to touch on with this and just give everyone a heads up on with these. When we are adding or subtracting the coefficients together, remember that the variable and the variable exponents have no influence or no say in how those coefficients add or subtract together. Meaning, we can be seeing problems like this where instead of having integers in front, maybe I have fractions in front, or maybe I have decimals in front, or maybe I have mixed numbers in front. With all of those scenarios, we still combine like terms the same way. We still look for the same variables and the same exponents attached to those variables as our rule with these things. I'm going to bring us back over here. We should have our answers on display here. Yeah, so there we go. Now, if you guys would like to, I do have some group problems that are listed out here. And again, the entire purpose of showing these things and having them written out in this way is just to show you guys that we can have fractions showing up. We can have decimals showing up with these things. The coefficients in front do not change whether we do or do not have things as like terms. Remember, like terms are based on having the exact same variable and the variables having the same exponents. If those criteria are met, then we add or subtract the coefficients together. And we've previously covered how do we add or subtract fractions and integers together? How do we add or subtract decimals together? So all the processes for adding those that we've covered previously are still going to show up there with these types of problems. I did also add in, just today, since it wasn't there previously, I did also add in an extra practice PDF for this material. And it's a big old mix of adding and subtracting things together. You will notice that with this, there are mixed numbers showing up in here, and there are mixed numbers in the final answer. I will not be giving you guys mixed numbers on the test with this material, and I do not want mixed number final answers. I'm just at the mercy of what the program is able to provide for me. So if you are seeing those, convert all of them into improper fractions first, and then solve the rest of it out as you would accordingly. So some extra practice ones that are here, it's got a mix of fractions in them, decimals in them, integers showing up within them as well. And all I've done with these is try and increase the difficulty and that there's just more things that are adding or subtracting within that as well. At the end of the day, we are coming back to our process of I'm checking for variables to be the same and variable exponents to be the same as well. And as per usual, with all of the extra practice PDFs and problems that we have written in here, the answer key is provided at the very end. You guys are welcome to use this, download it, save it, print it out as you see fit. If you are referencing this later on, and here's my YouTube streamer part here, pause the video at any time if you want to give any of these a shot, and then check your final answer with the answer key that we have listed here. I think it splits up into 2 pages for the answer key, but trying to go through it somewhat gradually if anyone's going to try and access this otherwise. We do go down to 120. So we've got, there we go, last one there. And apologies again for the way that the answer key is displayed. It's a little weird in that regard, but it is all there. So with that, that is everything for the 10.1 material. I'm going to go ahead and put us back to the notes. I'm going to end the recording. If you guys have any questions, I'm more than happy to go through them with you, get those clarified with 10.1 or anything else that you guys would like to go through as well. So give me a quick minute here and we'll open up to those.